All right, welcome back. First thing I wanted to do is talk a little bit about your little GeoGebra exploration that you did. Now, I know some of you still have like sharing my OneDrive folder issues and stuff like that, and we can talk about that in a little bit. And I also know that the links on these are goofy. Like when I click on them, it takes me straight to the function in graph 1, function in graph 2, but for some of you it took you to a different link. Some of you it took you to like the geometry one where you're doing circles and stuff like that. Did anybody run into that? I can't explain what the heck is going on with that. Don't worry about it. All I wanted you to do is show me that you were going through and trying to learn the software, trying to find, oh, what's under this menu? What's under this menu? How do I draw a line? How do I connect a point? Blah, 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 blah. I just wanted you to explore it. That's all I'm looking for. So if you didn't get every single green circle to punch in, don't sweat it. Okay, I'll give you completion points for doing it. But was there anything specific, like one specific function or one specific step that you just couldn't figure out that anybody wants to talk about? Hello? Any specific ones? Any specific feature, function that stumped you? Or are you all experts now? Going once? Going twice? We're comfortable? Okay. If you're having OneDrive problems or anything like that, let's talk about that right after class, and we'll see if we can figure it out. Okay. Very good. Let's see. 104. I remind myself what class we're in right now. Okay, so what we're going to do today, I updated our schedule. The first thing I want you to do is go to Blackboard. We are going to introduce section 1.3, which is rate of change and behavior of graphs. All we're going to think about the next couple days is looking at graphs and trying to understand increasing and decreasing and different behaviors and how the x-axis works with the y-axis and stuff like that. So the first thing I have for you is a fun little activity. I want you to go to Course Docs and Links and scroll down to section 1.3. Do you see Desmos Graphing Stories? I want you to click on that. Okay. And how many of you have ever done a Desmos math activity before? You've done it? Maybe your high school teacher used it? Yeah. Anybody else? You've done it? They're pretty cool. We'll do a few of them in here. What I'd like you to do is when you click on that link, it takes you to the activity. Does it give you a chance to like log in or to create an account?
Sign in with Google.
Yeah, what I'd like you to do is go ahead and create yourself a new, create yourself a new like username and password. The reason I'd have you do this is because a couple of these we're going to do where you might want to come back and finish it later. And if you don't have a username and a password, and then you click back on the link, you're going to have to start all over from the very beginning again. Does that make sense? So does everybody find where you can create yourself a username and password? This is the teacher version of it, so it's not going to look like that. If I click on that link, where we are, guys, is under 1.3, under Course Docs and Links, under that Desmos Graphing Stories. If I click on there, you can just join it, but I want you to actually sign in. So click Sign In, and how do you create a new?
There's no button for it. So.
Well, now I'm confused.
Just hit the join button and it'll lead you to it.
Oh, hit the join button. And now sign in. Yeah, create an account. There it is. Thank you. Thank you. Create an account. And it's just free. Give it I think it'll ask for a username or an email address, right? And go ahead and create yourself an account. I mean, theoretically, you don't have to create an account if you don't want to. However, like I said, if you're working on an activity and you put 20 minutes into it and you have to leave and come back later, you don't want to have to start all over again. That's why I'm having you create the account for you. And then what will happen, I'll show you what it looks like from my end here. If I go to Classroom Activities, I got to sign in. And if I go to history, graphing stories, I see 8 of you are in. And what you want to do is you just want to put your first name in. First and last is fine too. So I can see, now there should be 12 of you here. 1, 2, 3, 4, 5, 6, 7, 8. There should be 12 of you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We're missing 1 of you. Still working on it, Ryan? Okay. So this is what the teacher screen looks like. You guys aren't going to see this. And the idea here is there are different steps in this activity, and I can see who's on what step, and I can see everything that you enter into your screen. Okay? So don't worry about accuracy per se on this. I'm just going to give you the completion points for doing this activity. Okay? But obviously I want you to do your best. And what we do here is you just go through it and you just follow the instructions. And you're going to have to type answers into a box, or you're going to have to do a graph or something like that. And every once in a while I'm going to push pause and I'm going to shut you guys down, and because I can make your screen freeze, and I'll share like a couple examples of what somebody wrote or what somebody graphed, and we'll just have a little discussion about it. Okay? So is everybody on step 1 with the guy about to ride the slide? Okay? So it says there's a lot going on in this video. So watch the video. What different measurements are changing in this video over time? Just type something in, and when you have something typed, click share with class. And then go on to step number 2. And then go on to step number 3. Step number 4, and so forth. And we'll work on this for a good 20, 25 minutes. I hit the anonymous button. Did your name just change to some other goofy name? Yeah. So I can do it both ways. If I want to show what one of you wrote, like let's say Gage comes up with the most brilliant answer to one of them, and I want to give Gage some props, I'll say, hey everybody, look what Gage did. But let's say Gage comes up with like the silliest answer ever, and I don't want to embarrass him in front of the whole class. I'll say, hey everyone, look what Olga Toski-Todd did. Something like that. I won't embarrass anybody. Probably. So like I said, if you're done with step 1, go on to step 2. Step 2 is going to make you think a little bit.
Can you submit on step 2?
I don't think there is a submit button. Is there on step 2? It just kind of captures it as you go. So you can see I've got all 12 of you. Some of you, it looks like you're done. Some of it looks like you're still going. By the way, if you guys haven't figured this out yet, when you graph on this particular Desmos, you can do dots. like dot, dot. Let's say I'm like, oh, I know for sure this dot is on there, and this dot is on there, and this dot is on there. And then if you want, you can connect, with lines. You can do lines. You can erase different things. I don't really care how pretty you make it. This is more conceptual. Do I understand the relationship between time and the height of the person? Okay? Now, when you get to step 3, it's going to show you the answer. Okay? But don't go there until you're confident with your step 2. I see a lot of you are already on step 4 and 5. Okay, I just paused you. Did it stop you?
No.
Should have.
Yeah, no.
There, it took a while.
My video kept going.
Okay. Oh, sure. Okay. From your step 2, I just grabbed 3 examples. Okay. A lot of them were similar to these. One of these is different than the other 2, right? So I'm pointing at this one at the bottom. What's an issue going on with this one?
It's not right though.
It never comes back down, right? This makes it seem as though the person is like climbing the ladder, and the ladder just keeps going and keeps going and keeps going, and they just get higher and higher and higher. Eventually, the guy gets on the slide and he comes back down to earth, right? So this one feels a little unfinished, although it looks good for the beginning of the graph, right? This person just didn't finish the whole thing. Okay, the top 2 are similar, but there's one key difference that the person on the left did that the person on the right didn't do. The flat part, right? What does the flat part represent from the video?
His height stayed the same.
Say that again.
His height stayed the
His
same.
height stayed the same. When did his height stay the same? When he walked across the platform. Depends on if we're talking about the height of his head or the height of his waist. I mean, we could really nitpick this thing if we wanted to. So when he walked across the platform, he was not going up or down, correct? When else did his height kind of stay the same? He kind of sat there and just waited for a while, right? So time was moving on. Time is continuous. Time never stops, right? But did his height stop? Yeah, it did, because he sat there and rested for like a couple seconds before he decided to slide down. So this person is telling me, oh, he kind of walked across, and then he sat there and waited for a while, and then all of a sudden, he went down. Here's the other thing. The slope or the speed when he goes down the slide versus the slope or the speed when he goes up the ladder. Was one of them faster than the other? Typically, when you go on a slide, which one of the 2 is faster? Usually going down the slide, if it's a steep enough slide. Going down the slide is usually faster than going up the slide, unless you climb the stairs super fast and then go super slow down the slide. But I think he was a little faster on the way down than he was on the way up, correct? So what between this part of the graph here and this part of the graph here, one of them should be a little steeper than the other, right? And I think you learned that when you went to step 3 and you saw the answer. Okay? Do you see where I'm going with this? We're really trying to analyze the graph as much as possible, trying to get all the little intricacies that are at play so that we can give the most accurate representation that we can. Okay, I'm going to unpause you. Go ahead and keep working. Step number 4 gives you the next example. love looking at all 12 graphs. Is this making you think a little bit? That's our goal today, to get you to think about things. Like it just froze up or what? Yeah, did you create yourself an account?
Yep.
You should be able to like get out and then just go back to click on the link and resume by signing in. I grabbed 2 from the water one. I think it was Gage and Anthony. These are the 2 I like the best. I like one just a little bit more than the other. Somebody take a stab at which one I like better.
Second one.
Why?
Stops at 15 seconds.
Stops at 15 seconds? That's not necessarily why, but hey, good point.
There was water in the bucket when it started.
It didn't what?
It was full when it started.
Oh, I wasn't even looking at that. Yeah, look at the starting points. This person is saying that we started with 0 in the bucket, but this person is saying we already had some in the bucket before the video even started. Right over my head. Fantastic. What else about it?
Yeah. First one has like a more of a like quick.
This one, this chunk is steeper than this chunk. Which, if one of them is more accurate, it's really hard. That's a guess, right? I'm looking at this chunk versus this chunk, and the first chunk versus the third chunk.
Exactly the diameter.
Yeah, the whatever the sink is that's pouring into it, did that one ever change? No. So shouldn't this rate be exactly the same? And then when the big dump happened, whatever, and then this rate? Do you see how the 2 slopes of these chunks seem to be exactly the same? They're parallel. Whereas this one seems a little steeper, and then this graph would indicate that the sink slowed down a little bit. But did the sink slow down a little bit? No. So, yeah, again, I'm being really, really picky, right? But I really want you to look at the detail. Who did that one right there? Anthony. Which one? Aaron? Anthony. Fantastic. Okay. Keep working. I'll unpause you. Gage, yours was good too.
Thanks.
One strategy that you can use here is when you watch the video or you look at the situation, before you even sketch the whole graph, sometimes it's nice just to plot 1 or 2 or 3 or 4 points that you know for sure are an accurate representation of the graph. Like maybe the maybe plot the point at time 0, right? If I plot a point at time 0, that gives me a place to start. If I plot a point at the end of the video, that gives me a place to end. And then maybe there's a point or 2 or 3 in between that I know. And then when I have an idea of some of those points, then I can play connect the dots in between and fill in the entire graph. So that's one strategy you might want to try. Now, when you watch the answers, you don't have to go back and change your graph. That's okay. In fact, I'd rather you not. Okay? So leave your original graph for the eggs and the merry-go-round. Just leave your original graph, even though you might have saw the answer and said, oh, shoot, I screwed up. I should have done it differently. That's okay. I want to talk eggs for a second. 3 completely different graphs here, right? Which one do you like the best? The bottom one? Why?
I guess with the eggs, it's like a median.
Yeah, think about like the difference between the eggs and then like the water and the height of the guy on the slide. Like when I add water, it's in liters, right? Can I do half a liter? Sure I can. Can I do half of that? Sure I can. I can continue to take an amount of water and cut it in half and cut it in half and be smaller, 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 all the way down till I get to like 1 molecule of H2O, right? And I can do the same thing with time, right? I can take a second and I can cut it in half. I can take half of a second and I can cut that in half. So time is continuous. We can always get a smaller increment, right? Water we could call continuous. Certain things are continuous. Are eggs continuous? Did he take out 0.1 of an egg and then 0.2 of an egg and then 0.3 of an egg? No, he took out a whole egg all at once. So we're not technically, this is showing that the eggs just went from 5 to 4.99 eggs to 4.98 eggs to 4.97 eggs, and that's not what happened, right? It actually went from 5 eggs straight to 4 eggs. And it went from 4 straight to 3, correct? So do you see how this one is showing eggs being continuous? So that's not quite right, right? Now this one and this one, they're similar, right? But what's happening, time is still going on, is it not? So what's happening when from 5 to 4? Is there anything happening in between?
She takes her hand away, so it's flat.
It should be a flat line because it's like 5, 5, 5, 5, 5, 5, 5, 5, 5, 4. 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 3. Does that, right? So this one is good, but this one is kind of showing the immediate jump, right? So I only have one problem with this graph. Anybody want to?
Shouldn't have the lines going down.
It shouldn't have the lines going down because what it's saying now is at this time there was 5 and 4.99 and 4.98. Can there be multiple numbers of eggs all in one split second? No. So this one would be really good if we just eliminated this garbage here, right? And we just have a bunch of straight lines. And you guys learn that when you watch the answer, if you watch the answer already. So that's a little lesson in what we call continuous variables: water, time, height, age. Certain things are continuous. Other things are what we call a discrete variable. In this particular instance, we either had 5 eggs, 4 eggs, 3 eggs, 2 eggs, 1 egg, or 0 eggs. There was no 1.5 eggs, right? So we only went by whole numbers in that particular example. Okay. You guys are killing it. Nice. I'll let you finish here without me interrupting you. So go ahead and finish if you haven't already done so. If you're on the last step, 4 of you already are. You can make your own challenge. Did you die?
No,
No.
I'm close to it.
Oh, do you have your power cable with you?
I don't think so.
Do you need to borrow one? Well, go sit by the wall somewhere where there's an outlet. We're going to be using our computers pretty much all day, every day. So plan on that. So for battery charging purposes and whatnot.
Aren't 6 and 7 the same exact thing?
6. Nope. Read the y-axis.
Oh.
Distance from the camera, and then the other one is distance from the center of the merry-go-round, right? It is the same video, though. If you created your own challenge on number 12, you should have the opportunity to try somebody else's challenge. Has anybody done that yet? I can't remember how that works on this one. No students have submitted challenges. It looks like a couple of you have one that's close to ready to go. So you can see at the end, they're asking you to make your own. Same video, but maybe measure something different in the video. Okay, in the interest of time, I'm going to pause you. I'm going to show you one challenge that one of you presented. It says, sketch the relationship between the graph, the amount of water in the measuring cup, and time. The amount of water in the measuring cup. So, how much is in there? If I were doing that, it's probably got, I don't know, it's got, I don't even know what this is in. If this is like milliliters, does it say? Anyways, there's some water in the measuring cup, right? And it's in there, and it's in there, and it's in there, and it's in there, and then at some point in the video, I don't know how many seconds it is, it basically goes like this. Do you guys agree? There's water, there's water, there's water, there's not. And we're down to zero, right? And then for the rest of the time, we would be at, that's how I would probably answer that question. So again, in the interest of time, I'm just going to cut it off right there. I hope you had a good experience with that. I think the Desmos are kind of fun. I don't know if you guys find them kind of fun and challenging, but I want you to look up at our standards of mathematical practice again and ask yourself, did I have to do any of these things? Did you have to make sense of a problem and persevere in solving it? Of course you did. Hopefully you had to sit there and try to make sense of it. We didn't really reason abstractly so much. Construct a viable argument and critique the reasoning of others. We can pull up other people's graphs and critique them, both positives and negatives of somebody's graph and their reasoning. Of course, we modeled with mathematics. Anytime you create a graph that models a situation, that's what modeling is. Okay, so we definitely did number 4. Use appropriate tools strategically. We used our Desmos. We used our plotting feature, right? Attend to precision. One person started the graph at 0 in the water bucket. The other person was more precise and said, no, it doesn't start at 0. It starts at like 1 or something like that. So they were very precise in that one. Okay. Look for use of structure and regular and repeated reasoning. Like a repeated reasoning would be the slope of the sink filling the bucket at the beginning is the same as the slope of the sink filling the bucket at the end. That would be, you saw a pattern going on there. So again, all of these things come into play in almost everything that we do. I'm going to give you another one here. I'm going to exit out of the Desmos. If you go to right underneath that link on Blackboard, I took a snapshot of the trip odometer on my car. Okay, that's the trip odometer. Notice the total miles is like 36,000, whatever.
Are we good with the dev?
Yeah, we're good with the Desmos. Yep, you can exit out of it. What I want you to do is just look at the trip odometer. Okay? Since I must have pushed reset on the trip odometer at some point, okay, when did I push reset on the trip odometer? Well, 62 hours and 56 minutes ago of my car being on, right? Of the engine being on. And how many miles have I driven since I pushed reset on the trip odometer? 19.9 or 1,620 miles, okay? So what I want you to do is I want you to try to make a graph of Jamie's driving, okay, on the attached car odometer graph, GeoGebra. Can you open that up? So go ahead and open it. Notice that I already labeled the axes for you. So the x-axis is time in hours. Time in hours. And the y-axis is the distance, the miles driven. Okay? So before we even make this graph, are there any points that are on the graph that you know for sure that are on the graph? 0, 0. Explain that to us, Anthony.
Because I guess when you first reset it, it goes to 0.
Right. When I pushed the reset button, that started everything at 0. So do you guys agree we could plot the point 0, 0? We definitely know that point is on the graph. Is there another point that you know for sure is on the graph?
19.9.
Right. That's the distance driven. So that's my y, but what's my x?
62 hours and 56 minutes.
Yeah, 62 hours and 56 minutes. Now, be a little clever here. 62 hours and 56 minutes. Is that equal to 62.56 hours? No, of course not. Because there's not 100 minutes in an hour. So it's not that, right? So let's just round it. Let's just call it 63 hours. We could figure out the decimal if you wanted to. 56/60ths, whatever that comes out to be. Just round it to 63. I don't care about that. So we know that the point 63, comma, I'll just round this to 1620 miles. We know that that point is on the graph. So I have my beginning point and I have my ending point. Now what I'd like you to do is see if you can complete the graph. Connect those two dots. Now, a good way to do this is, see underneath the pointer tool, there's a pen. Go ahead and grab the pen. Now, if you have a PC, you can use your finger. If you have a Mac, you don't have a touchpad, right? But if you have a PC, you can actually draw this graph with your finger if you have the pen up. If you have a Mac, I think you're going to have to click and hold and drag your trackpad, right? And I'm going to come around and look at your graph. So you're trying to connect point A and B. Now, do you know how Jamie drives? No.
Whatever, just like
How am I supposed to know
assuming that you just like driving the
if
whole
you want a
time?
long way, if you want a short way.
Well, we know how far I went. 1,620 miles, right?
One shot then.
Was it in one shot? I don't know. So, is it very possible that all 12 of your graphs are going to look different? Are you taking a total guess at this? Of course you are, right? But are there certain things that must be true on your graph? That's what I want you to think about. Is there a wrong way to draw this? Because there's certain ways that you could draw this that are impossible, right? Were you raising your hand?
No.
Oh, okay.
So why is mine not loading like?
Did you open it straight from...
Yeah.
Do you have it... Okay. You're on like the web version, or what are you on? Close this out. Okay, click on that. Wait, first?
Oops.
Yep, no, that's fine. GeoGebra Classic.
It just goes to your like original.
Um,
Kind of goofy or what?
your keyboard is opening for some reason. Your axes are not labeled.
No.
Yep, I don't know what's going on. So this is like the, I don't know where you are. Let me see.
No,
What happens if
this
you
is
just open
closed.
GeoGebra? Okay,
That's from
so that's different.
when we were
See,
working on
this
it.
is different than what was just opening on your screen.
Yeah.
So
it's like that.
somehow when you open this, it is
I should delete some.
having
tabs
you
too, huh?
here. It's. I'm gonna go to your.
Did I not download it?
I'm gonna go to your download and open that.
See, oh,
It-
that might have worked.
It should
That might have
open.
worked.
It should open with GeoGebra, and I don't know.
Yeah, I don't know.
I don't know what's going. I don't know what this is. This is like the.
It just looks completely different.
It does the menus, and plus it just opened a. I don't know what's going on with yours.
Yeah, well,
We'll have to figure it out. Okay, I'm looking at some graphs. I am really liking. None of you have made the fatal flaw that I thought you were going to make. Come on, somebody screw it up. Gage kind of screwed it up.
I think we did it once, good.
So, well, I can tell you that I did not drive 63 hours without at least stopping once. Right? So, okay. Do you think it would make sense for this to be a perfectly straight line? Would that make sense? Only if what?
Same speed.
I went the exact same speed for 63 hours. Basically, I got on the interstate, I set the cruise, and for 63 hours, I never sped up and I never slowed down. Is that probably not what happened, right? What about something like this? What if I did something like this? Could that happen? Yeah. Every single time that this graph goes down, like I went down right here, and I went down right here, and down right here, and down. Every single time that that goes down, what is that indicating?
Like negative lines.
Yeah, like my odometer went down. Do odometers go backwards? On really, really old cars, when you used to put them in reverse, the odometer would dial backwards, but that doesn't happen anymore, right? So we know that it can't go down. So I was very happy to see that most of you did something like this. You know, where there was some variation in there, but it never went down. Gage, I saw one little nugget of yours that looked like it went down. That's why I said you may have.
I don't have a pen.
Oh, yeah. Yeah. So again, conceptual. That's all I was trying to get is, can you think about the relationship between a graph and between a variable? But overall, very nicely done. I'm done with that activity. Comments? Questions? Before I close out of this, if I asked you what is well, first of all, if I use this graph that I have on the screen right here, if I zoom to a certain point, let me do this. I'm going to zoom in on a certain point here. Okay. There's different slopes going on here, right? What does the slope represent?
Kind of how fast you go.
The speed. Yeah, the rate of change, right? So like at this point right here, at this point right here, it looks like I was going about this fast, right? Like if I did the slope right there, that's how fast I'm going. But at this point right here, what's going on right here?
Driving down.
Same speed.
Am I coasting? Am I going the same speed?
Oh, you're stopped.
I'm stopped. I'm in park, right? Because time is moving on. Is my odometer moving up at all? If it truly looks flat, flat means I'm in park. Or if it's just barely moving up, I'm probably in a parking lot just crawling along at really, really slow, right? So every single instance, every single second, I could say, oh, there I was going 75 miles per hour. Oh, there I was going 0 miles per hour. There I was going 32 miles per hour. There, right? Every single instant that you're driving, there's some speed associated with that drive, right? And when you get to calculus, you can actually figure out that instantaneous rate of change. But we're not in calculus. So instead of thinking about an instantaneous rate of change over time, we often think about an average rate of change. So on average, over the course of this entire 63 hours, how fast was Jamie driving on average?
25
How did you get that?
You divide the total miles by how many hours?
Exactly. If you take total miles, which is 1620, and you divide it by total hours, wouldn't you get miles per hour as an average over the whole darn thing? So if I take 1620, or what was it, 1619.9, and divide it by 62 and 56 60ths, whatever that is, I'll just round. So 1620 divided by 63, it's about 25.7. What's the label on that? Miles per hour. Yeah. So it's about 25.7. Watch what happens then. I'm going to get rid of this. Watch what happens when you just connect it with a straight line. And we just assume that I set my cruise and went in a straight line the whole darn time. It gives you an equation, and if I change that equation to slope-intercept form, notice the slope. It's the exact same thing we get if we just divide the two numbers, right? So on average, that's what it looks like. That's the average rate of change between point A and point B, even though we know that it was tons of different types of rates of change in between. That's the average from the start to the end. So in the next section, or on Friday, we're going to talk more about average rate of change. Okay, we got 1 minute left. I'm going to tell you your assignment here. Go to Blackboard. Do you see the PDFs called 1.3 card graph matching? Okay, open that up really quick. It's going to give you 10 scenarios. Number one, Tom ran from his home, blah, blah, blah. 10 scenarios, and then 10 graphs. A, B, C, D, E, F, G, H, I, and J. Your goal is to match the scenario number with the graph letter. So 1 goes with C, 2 goes with F. It's a matching game, right? So just do that kind of on paper. You can print this if you want. You don't have to. When it comes time, when you have all your answers, and you know number 1 goes with this, number 2 goes with this, and so forth, I want you to enter your answers into this 1.3 card graph matching quiz. So this should only take a second. This already means that you have all your answers. This is just entering your answers. So I can have it electronically so I don't have to print it out and have you hand in paper. Okay? So if you think number 1 is D, D goes with Roman numeral V, so you would choose V. And just match it up. And when you have it matched up, save and submit. It's worth 5 points. You only get 1 crack at it. Any questions? All right. Have a good one. See you on Friday. Also,